Goal of this presentation is to learn the basics of regular expressions and look at a few applications to hopefully convince you to learn it yourself. So, what is a regular expression? In short, I like to think of it as Control F, but more advanced. So instead of searching for a specific set of characters, you can use textual patterns to look at stuff a little bit more efficiently. So this is good for searching, for validation, and replacement of text, and it can be done really, really fast. So learning regular expressions will help you work faster and also help your programs work faster as well. So you can use regular expressions like you would Control F by just listing the characters that you want to look for. In this case, I'm looking for a needle in a haystack, but it doesn't really make sense to use regular expressions here because you can just use Control F. But that all changes with using character classes. So if you were to have a period in a regular expression, that is not going to be a literal period. That is going to match for any single character that isn't a new line. And then same with the \W, \D, and \S. W is any alphanumeric character that it also includes underscore. D is any character that's a digit, and S is any white space character. So that would be, space, tab, new line. And the uppercase versions are essentially inverses of those. So capital W would be any non-alphanumeric character or underscore. Any capital D would be any non-digit, and the S would be any non-white space. You can also use square brackets to specify a list of optional characters. So if you put ABC in brackets, that would match for any single character that is A, B, or C. And then you can get the inverse of that by putting a caret in front of the ABC or whatever text you want to look for. And you can also specify within the square brackets a range of ASCII characters by putting a hyphen or a dash in between them. So in this case down here, it's A through G. Any of those letters will be matched. So here's an example that I created. This is a pattern that should match a WHI manufacturer code, ensuring that it's also uppercase. You can see we have 3 sets of square brackets. They all have the same contents. There's an A-Z that is any uppercase letter, followed by a \D, which is a digit. So that basically means we want 3 characters, and each of those characters is either going to be an uppercase letter or it's going to be a digit. So we can see WHI, Wix, 1DZ, 111, all of those fit just fine. But these ones don't match because this one has all lowercase, and then these ones have special characters in them that are not valid. Then we also have quantifiers and alternations. So quantifiers allow you to specify more than one or a set number of the preceding token or character. So with the letter A being used here, putting a star after that means 0 or more. So you could have 0 A's and the match will still be valid, or you could have 1 or an infinite number. If you had a plus, that means 1 or more. So you can't be 0 A's, but 1, 2, 3, infinite number, those are all fine. Then you also can specify a question mark. The question mark is 0 or 1. So you can have 0 A's and you're fine, or you can have 1 A. And if you had more than 1 A in this situation, it would just match for the single A, and the text after it wouldn't be part of the match. If you want a specific number, you can use curly braces and just put that number in here. So if I want specifically to match 5 A's, instead of typing A 5 times, I can just put 5 in curly braces after the A. This can also be used to specify a range. If you have 2 with a comma, that means anywhere between 2 A's and an infinite number. And if you had a range with two numbers in here with a comma in between, that means between 1 and 3 A's. You can also put a question mark after a quantifier, and that basically just means even if there are, say, more than 2 A's, or more than 1 A, it will match just on 1. It'll match as few as possible. And in this case, because it's between 2 and an infinite number, it's only going to match on 2. You can also use the pipe character as an alternation. So that allows you to choose either or. So either A, B, or C, D. You have two options for the match to be valid. You could also chain more pipes here if you wanted more options. We could have a pipe with EF after here, and then you'd have 3 to choose from. That's valid too. And looking at that, quantifiers and alternation in action, I created a pattern here that shows it. We have two pipes here that are alternations, which splits this regular expression into 3 sections. We have one here, and one here. If any of these sections match for the text, it'll pass. So the first one is eBay with dot plus, which means eBay has to be specified, and then any character that isn't a new line, one or more. So in this case with eBay alone, it won't fit because it won't match because eBay doesn't have any text after it. But eBay Motors has text after it, so it will match. And then with the other section, we have WHI with dot star. Dot star is going to be any character 0 or more. So WHI staying on its own, it doesn't have any other characters after it, but it's okay because it's going to match on 0 or more. But then we also have WHI solutions, which is extra text after it, and that works too. Then we also, in this third section, have 2 to 4 A's followed by the number 1 and an optional letter Y. So here we have A1, and then we have 5 A's with a 1 after it. These won't match because it needs to have between 2 and 4 A's. So these 3 in the middle, they match because they have, this one has 2 A's, this has 3, this has 4, and they all have the number 1 after it. And this one actually has the letter Y as well, which was optional, but because it's there, it's included in the match. This one has the letter X after it, which isn't part of the match, but because the Y was optional, this is still considered valid. Then we also have groups and references. Groups are really good for extracting specific information from a pattern that you're parsing. It can also be used for replacing stuff really well, but it allows you to specify a sequence of characters. So if you had ABC in parentheses, that the parentheses creates the group, and then ABC is going to be a sequence of capital A followed by capital B followed by capital C. Then you can also you can have a named capturing group. I don't usually use this, but this is if you wanted to, in your code, reference a group by name instead of by index. It's not particularly useful outside of that, so I don't usually use it. But then you can also have a numeric reference or a back reference to a group. This is especially useful. What it basically does is this number references the index of the group, and it basically says, let's say ABC was our first group in the pattern. If you had \1 somewhere later in the pattern, it basically is going to say anything that's in that first group must also appear at this point in the pattern too. So that's very useful, and I'll show an application of that. Then you also have non-capturing groups. This is more or less when you just want to apply a quantifier to a sequence of characters. You don't want to do anything with the actual underlying text itself. You just want to, for matching purposes, specify, like 1 or more, or 0 or 1. It's good to apply a quantifier to a sequence of characters instead of just one. So here is quantifier or groups and references in action here. I created a a pattern that is going to match on some ACES application data in XML. It's just going to extract the tag name as the group, and the whole tag is going to be matched. And we can see that first group is right here. We have the W for any alphanumeric characters, including underscore, is going to be the tag name. And the plus means it's going to have one or more. So that's going to be the first group. And then you can see here, this is a good example of using a non-capturing group. We are specifying the text that will be the attributes of the XML tag. So you have, in the case of base vehicle here, you have ID equals 1. That's the attribute. Not every XML element is going to have these, so this is a good example of using a non-capturing group. We can put a question mark after it, and that means it's essentially optional. You don't have to provide it, so like, with quantity, this tag here doesn't have it. That's okay. We then close the tag, and we have dot star, which is any amount of text within the actual element itself. And then to end, we have a forward slash at the tag here, followed by, here's that back reference to group 1. Group 1 is, again, going to be the tag name. So this is a really good application of using a back reference because we know that the name is going to, for ending the tag, is going to be the same as beginning. So that's a good application there. So where can you actually use regular expressions? I most commonly use them in my text editors. So SSMS and Visual Studio Code both have good functionality. If you use Control F, there is a option you can enable that it's like a little dot star symbol. If you turn that on, it will enable you to use regular expressions in both of those applications. Then you can also use it in Python. I use it a lot. Python has a built-in regular expression module called RE. You just import that and you can use regular expressions in a variety of ways. Basically, any modern language is going to support regular expressions. So if you use, like, I think PowerShell scripts support them, and I know like C# does. Basically, any modern language that you try programming with is going to have regular expressions. So let's look at a few use cases. I think the number one that I use regular expressions for is input validation. So I created a pattern here that determines whether an ACES build version is valid or not. So if someone is running a program to run it for a specific build, this will check to make sure that the build version they provided is actually a valid build version. It's going to start with the letter V, followed by 2 digits, and then the letter A or the letter E. And then it's going to have a number that's going to be 0 padded 1 through 12 for the month, followed by the letter R, and finishing off with either the number 1 or the number 2 for the revision. This doesn't include legacy versions, but you could certainly modify it to match on legacy versions as well. But yeah, this is going to match for a pre-elastic build version or a post-elastic build version just fine, and actually extracts that information for you that you need as well. You can also use it, regular expressions, for query formatting. So this is another very common application of regular expressions, at least for me. I will usually, if I want to get a comma-separated list of all the columns in a table, I just get the create table definition for the table that I want the columns off of, and I will use a regular expression to extract that text for the columns and replace the text with just the column names. So right here, looking at this pattern, it has to start with a tab, followed by square brackets, And you can see I actually use a backslash on the square bracket to make it treat as a literal square bracket and not as a special character class. So yeah, we also, here we have a backslash W plus, that's going to be the column name, and then finish off with another square bracket. Dot star means any of this text afterwards is going to match, and then finishing off with an optional new line. So these ones, because I'm running just off the selected text, these two are going to have new lines. This one, the new line isn't in there, so that's why I make it optional. And then I replace it with $1. That's how I refer to in the replace, that's how I refer to the first group, which is that column name. And then I put a comma there. So that means it's just going to have all of the column names replaced there with a comma at the end of each. Now, if you're going to use this, you probably want to remove that last comma right here. But then you can copy this and paste it into an insert statement, which, it's not very useful for a 3-column table, but seriously, when are we working with 3-column tables? Most of the time, we're working with, 10 columns, 15 columns, maybe even more than that. And that's where using a regular expression is really, really useful. And then this is essentially the same thing. It's just a different approach that I actually use more often, even though it has more steps, just because it's simpler. The expression is a little bit easier. I basically copy the create table statement, I put it into VS Code, and then I get something to specifically only select the text in the columns. I then use a VS Code shortcut, Control-Shift-L. If you use that, you can select only the stuff that's in the match itself. So you can then select all of the column names specifically, use Control-X to cut them, and then you can paste over all of the text remaining to get a list of the column names. Then you could replace, say, like a new line with a column, and you'd have a comma-separated list. Even though there are more steps, just because of those shortcuts and how much simpler the regular expression pattern is, I usually end up using this more often than editing directly within SSMS. Another use case we have here is for finding table references in a stored procedure. So if you're in a stored procedure, there are multiple ways you can specify a table. You can just use the name, you can specify the schema, database, server, and then you can also put square brackets. That's also considered valid syntax in between any of those. So I created a regular expression here that allows you to look for a specific table, and it will be independent of any of that stuff. So if you had the server, the database, the schema in the name, with or without square brackets, all of it will match. And in this case, I was looking for the WHI menu table, but you could plug in your own table there, if you know what you're looking for. And if you decide to pair this with the procedure backup repo that's available on GitLab, that's our repository of all of our stored procedures, you could essentially use this to search for a reference across all of our stored procedures, which is very powerful, something that I use all the time. Another use case is for parsing. You can parse very, very fast with regular expressions. In this situation, I wanted to try parsing a unique set of part numbers from an ACES file. This is, I think it was around 3/4 of a gig in size, and it ended up doing it 5 times faster than using a traditional XML parser. You can see here it only took just under 6 seconds with regular expressions, and it took almost 30 seconds with the traditional XML parser. So this is really, really useful. That said, it's also worth noting that you should really only use this for heuristics and stats where 100% accuracy isn't like critical. And that's because there are some things like, let's say you had a comment with a commented out application. In that situation, if there's a part number tag, the regular expression will still count it as a part number used. but an XML parser would recognize that's a comment. I'm not going to count that. So in this situation, there was, there's no scenario where there was a part number that would have been counted when it shouldn't have. So it's no real concern here, but it could happen. So for the sake of getting stats, like I think I used this for the region 4 when we were looking at those attributes. The presence of region 4, I think I used regular expression for that. It can be done way faster than an XML parser, but again, only use it when you don't need to be 100% accurate all the time. And one last use case right here is you can leverage regular expressions in SQL Server itself through a COR function. It is a little complicated, but you can write your own COR function to use regular expressions with C#. If you write a module in C#, you can then compile it to an assembly that is then loaded and linked as a SQL Server scalar function. It is, again, it's a little complicated to do, but I have a few functions the CDR does to format and normalize the URLs that we receive. If you'd like to learn how to use this kind of thing, just reach out to me and I can provide more information on it. And then to just finish off, regex1.com is a great resource I wanted to share. It is what I used to learn regular expressions myself. It's just a set of interactive regular expression lessons. And then regexer.com is another site that's useful. That is for testing regular expressions, and also it has a cool feature. It allows you to put in a regular expression and get a step-by-step explanation of the pattern, which is also very cool. For some of the slides earlier, I actually used regexer.com for that. But with that, that's it. Again, reach out to me if you have any questions, and thank you for watching.